Dear friends, in this video, we will take an example and understand hypothesis in action in the context of decision making. Let's look at an example problem. A retailer is selling morning breakfast cereal to sell as 250 grams packet. A customer has complained that the cereal packet he had bought previously weighed under 250 grams. The retailer decides to check the weight of 36 packets. He finds that the average weight is 248.5 grams with standard deviation 4.8 grams. Is the retailer selling underweight packets? That is the question. Let's see how to investigate this by doing a step-by-step approach to hypothesis testing. The first step, formulate the null and the alternative hypothesis. Mu is the population parameter, which is the population mean of the cereal packets. That is the parameter, and we are assuming status quo, the null hypothesis mu is equal to 250. Because if you look at the problem, it says that generally the retailer is selling morning breakfast cereal as 250 grams average packet. That's what his assumption is, that he is doing that. Every packet weighs 250 grams. That is the hypothesis he believes. The customer complains it is less than 250. So the null and the alternative hypothesis is as follows. H0, which is the null hypothesis, mu is equal to 250 grams. HA, the alternative, which we would like to prove with evidence, if possible, based on the evidence we have, mu less than 250 grams. So this is the first step. Now, how do you go about doing that? We need to use the second step, which is select the appropriate test statistic. We use Z stat here, Z equal to X bar minus mu divided by sigma upon root n. Now, X bar is the sample statistic based on the sample, in this case, which is the sample mean. And if you go back to the problem on a sample size n is equal to 36, your X bar is 248.5 grams based on a sample size of 36 packets. And the sample standard deviation is given as 4.8 grams. Now, assuming that it is a representative random sample, fairly adequate to say that the sample standard deviation can be approximated to represent the population standard deviation sigma. So we substitute X bar equal to 248.5 grams. Mu is equal to 250. Sigma is 4.8. N is 36. So under the null hypothesis being true, we are substituting here mu is equal to 250. So we compute the Z stat, which is the third step. Under the null hypothesis being true, I compute the Z stat 248.5 minus 250 divided by 4.8 upon root of 36. In other words, this 248.5 is X bar, 250 is mean, population mean mu, and 4.8 is the standard deviation sigma, and root of n is 36, we simply substitute and compute the value. It happens to be minus 1.875. So let's move to step 4. Draw the diagram and mark the z-stat value. Now, the distribution of z-stat, z, which is a standardized variable, follows a normal distribution with mean 0 and standard deviation 1. So when we draw the diagram, we just represent 0 as the mean, and z-stat computed, we are simply marking z-stat is minus 1.875, as you can see in the previous step, which is the computed value. And therefore, we mark it here. It is left of the mean. So minus 1.875 is marked. This is the fourth step. The fifth step is compute the p-value based on z-stat. Probability of z less than minus 1.875, which is the computed z-stat. And we are getting this value here as 0.0304. So 0.0304. Now, how do you get this value? We can use the Excel function, which I can show you here. Let us put here is equal to a formula norm dot s dot dist. When I put this in the brackets, I will have to substitute here the z-stat computed, that is minus 1.875, and the cumulative distribution being the normal, we put here 1 to represent cumulative is true. If you put 0, it is false, but we need to put cumulative. Then we close the bracket and compute this. Let's put this with 4 decimal places, number and decimal place. So when I put this, we get here 0.0304, which is the value which we get here, 0.0304. So the p-value is computed. This is step 5. Let's move to step 6. If the p-value is less than alpha, reject H0, which means if I reject H0, I accept H1. When alpha is not specified, take it as 5%. Alpha is called the level of significance of the test, or the significance level which you desire before the start of the test. You just set a value. By convention, when it is not given, we take it as 5%. You can also take it as 1%. Now, what is the decision? Whenever the p-value is less than alpha, you are rejecting H0 and then accepting HA, which is the alternative. In this case, since p-value 0.0304 is less than 0.05, we are rejecting the null hypothesis and accepting the alternative. The null hypothesis being mu is equal to 250, the status quo is rejected. The alternative mu less than 250 is accepted, and therefore we are inferring the retailer is selling underweight packets. So you need to investigate. So p-value is the actual risk which you are taking of going wrong. Alpha is the desired risk of going wrong, which is 0.05. In other words, rejecting the null hypothesis when it is true is called the alpha risk, which is 0.05. Now the risk is even less, 0.0304. Therefore, the null hypothesis is rejected. To make it simple, compute the p-value. If the p-value is less than alpha, reject the null hypothesis and accept the alternative. In this case, we are accepting the alternative mu less than 250, and therefore we are saying the retailer is selling underweight packets, which is the conclusion, and therefore you need to investigate and take corrective action. So this is the beauty of hypothesis testing in a systematic way of following 6 steps. I hope you have gained some knowledge about the basic principle of hypothesis testing in the context of decision making. Thank you very much. We will see you soon in another video.